backpack, it's very simple. It has a place and a note. Oh.
I have to zoom it anyway. Okay, yeah, go.
And the place, it comes already with backpack number 1 selected. What this means is, well, this backpack is wired to backpack number 1, so you don't actually need to change this place. The reason why we kept it is because you could actually get an external speaker and, you know, use it in the arm, for example. So we didn't want to lock it to the place 1, so you can have multiple speakers if you have them. But the basic input it receives, it's a note. And this note we have here like a list of like from A, B, C, D in a few different octaves. So you can actually do like very high pitch and not. But these notes, they are, even though you have them as, you know, note names here, they are actually mapped from 0 to 1 in terms of, you know, for example, note C6, it's equal to the number 0.895. What this means is I could actually get, well, any node. For example, wave. And I can get that wave directly into the buzzer. And what this means is that, well, let's hear it.
So that's a frequency you're just putting, or is it? Or is it the amplitude?
You're hopefully gonna understand it now. So this is the wave going from 0 to 1.
Yeah, and it changes the frequency over time.
Yes, it's changing the frequency by looping through different nodes. So the 0 corresponds to A1.
Okay, I understand.
And the 1 corresponds to D8. So the way you, instead of just thinking in frequency, you can imagine like a big piano roll, and first key is 0, last key is 1, and you are like swiping.
But that is why that's because you put it in the buzzer like function, because because the frequency is.
Yeah, that's the thing. We're not really talking frequencies here, because the problem with frequencies is that they scale up in a logarithmic scale. So it would, you know.
But you play a pure note for short time, and then you change to another short time. Okay, so you.
So we actually have the notes.
Okay.
That's what it's getting. So because we can always make the reference to a piano, and like have that as a. So you could create a little piano and have the notes going directly. But again, I mean, that's what we want to experiment, right? If we feel we need a buzzer that takes in a frequency, we might as well just do that.
Do you have that documented? Because if I would go to KTH with this, and they know about frequency, and they just take a sine wave and put it in, then they should assume it behaves differently. I understand what you're talking about, but if it's not if I saw this, I wouldn't think that you did that, because you think you do something else.
I hear you. I mean, it's something we've been pondering too. I mean, it's always if this is the first example you see,
that's no problem. But if you think you put in a sine wave into that component to the buzzer, then you're learning the wrong thing, because it wouldn't sound like that in the real world. So just to it's a good point. One thing we can do too is, for example, if we make a list, and on this list, you know, we could write a few notes in here. So I'll start with silence, so no note, and then note C2, note
Am I in the...
No, it's perfect.
Note D2, note D3, note D3. And if now I have this wave going into this list instead, so now I actually have a very clear of what are the notes that are actually playing. And let's load this. So now I have a limited set of notes, and then that can be more interesting to make music.
And the duration for each note, can you change it, or is it the same with
Well,
the
now
light
it's
effect?
actually following the wave, so the duration of the wave.
Yeah.
So if I wanted to stay longer in a note, I could just repeat that note.
Yeah, okay.
So
you have,
that note would have two
twice.
slots.
Yeah,
in
okay.
But it gets really interesting when you start to adding interactivity to this. So turn it off. So I could add a squeeze sensor, and I can get that squeeze sensor to actually control this list. So I'm going to put the squeeze sensor in the horn, and I have the light sensor in here, and I made a little lightsaber. Let me upload this. Placed it here. Oh, there we go. And then you can.
Is it working with a threshold now, or is it analog?
Well, it's no. This one, it calculates. It's self-calibrating, right? So whatever.
And is it doing that constantly, or just when you reboot
it? Does on the start.
Yeah.
Yes.
Okay.
So it's good to know. So if you want to calibrate it again, you turn it on.
So you want to start it with the full sensitive, or you can change.
You need to teach it the sensitivity when you start. So I mean, the first thing I do is to turn it on.
Yeah.
And then press it, because now it knows what is the brightest, and it knows what is the. So that can be an interesting activity to like, and that we could combine with the infrared sensor and play the notes like that. I'm gonna show a bit of the infrared sensor too.
Det blir typ som ljusorkestern. Eller? Man skulle kunna göra ljusorkestern.
Ja, den som är där nere.
Ja.
Ja,
genom att liksom.
Ja.
Kan man.
Ja.
Yeah, because you could, instead of the squeeze sensor, use the light sensor that doesn't calibrate, and then you have something like a flashlight. And when you flash the light on, it will start playing, or turn off the light in the room.
Okay, so you have squeeze and okay, so they are just the opposite. One of them are like low if you have full brightness, and the other one is
two differences.
like
one is exactly like squeeze sensor what is 1 means the most squeezed, right?
Yeah.
So it's measuring
Yeah.
the squeeze.
Yes.
and
So it's measuring the less
less light.
less light, the more
And
squeeze.
the analog sensor is
The opposite,
measuring
yeah.
the opposite. So, but the other difference is that the squeeze sensor also has this dynamic range. Because
Yeah, okay.
we want to be able to squeeze into a dark room and in a bright room and have the same effect.
Yeah.
So it calibrates to the light. The light sensor has no calibration.
Okay.
So it takes what light is in it.
Yeah.
So it's these two differences. So, you know, with the light sensor...
And it's more like an on-off switch? Or
No, you actually have a
you
range.
have the range.
So
Okay.
let's do it. So I'm just gonna get a... Instead
But you don't get an analog signal from it. It still goes. It has a threshold between the in the middle of the range.
No,
It
it's...
changed.
well, let's see here if it makes it clear with an example. So, got a light sensor here. And I'm going to put it directly into the buzzer because I
Yeah.
think it's easier to hear it. Oh, sorry. So the light sensor. Light sensor into the horn. And the buzzer.
Yeah.
So I mean, that's the advantage of having the notes just being the 0
Yeah.
to 1,
Yeah.
because then it's really plug and play with any note.
But then I understand your problem with the software library and having the real-time calculation of everything.
Yeah.
So it's
Yeah, it
really
is.
heavy.
I mean, it is already a very, you know, there's a lot of functionality that when we want to implement, we need to think like, okay, how is the most optimized? Because, yeah, we already consume a lot of the power
Yeah.
of the processor. Okay, so let's see this one because it's also very fun. So I think I had an example of it.
Do you had any problems with timings when you combine different blocks of functionality?
You mean
Because
like
you
the
don't really have the
taxing
parallel processing power in that.
Yeah,
so you
I
have
mean,
to-
I have some like it's like a performance test that it's like every single LED
Yeah.
and every motor and this test passes. So I mean, it was very recent. I actually refactor a lot of the library, and I got like a few notches up in performance. So yeah, I mean, sometimes you step into a corner when you have a lot of things going on, but now for the interesting thing is that when you get to that level, then the clutter here
Yeah.
also avoids you
Yeah.
to reach that far. So
Yeah.
it keeps you within.
So don't buy a bigger screen.
Yeah.
What happens if you switch from code to text mode?
Yeah, sure. Then, yeah, I'm gonna talk about this specifically because we now, and I think you're gonna like this, like we made a much tighter integration with, you know, with Arduino, but
Yeah.
the imperative approach. So we actually now can support both in a much more interesting way. But okay, this code here, it's basically creating all the nodes, then, well, setting them up with like the minimum and maximum, so like all these values, like 1, wave sign, 0, 1. So it configures them. and makes the connections. So you have, for example, LED light connect to wave out. You have them all connected, and that's pretty much it. So I mean, it's a straight-on translation of what you see. Like you have every object in here becomes one variable in the code that connects to another variable. Okay. So
And you still, in the text code, you only call a function all the time. You can't see the actual code.
what is
of the
inside
function.
the code? No.
No.
And this goes to another topic. This is also something we're discussing, that the ability to create a node builder, that you can create your own nodes and therefore be more exposed to that. The main reason why on this context it wouldn't be so interesting to really show what is the code that makes this is because this code, it's actually high optimized ugly C code. It's not like a 10-year-old level. It's like it's too much. But once you can create your own nodes, then we can take an approach that a simpler way to do it. Okay, so maybe I'll do 2 examples. So the proximity buzzer, it's very nice because it's very simple. It needs no configuration because it's already wired in the right place. So you put the backpack and it just have, okay, what is the minimum value? So when it's, when everything is far away, and what is the maximum value when you're very close to it? Default to 0 and 1. And what you could do is you can get this.
And that is also self-calibrating every time you start it up, or?
No, I mean the range is it's the actual range. It has a lot of noise filtering though, so it's like a smoother value. But the way that's more technical if you don't know. But the way it is implemented is it takes at one step it shines the infrared light, takes a measurement of how much is that.
Yeah.
The next step, it turns off and takes a measurement. So you